Okay, good evening to you all. Now, today I'd like to respond or continue responding to a question that has been troubling a few of my students. And most probably, it's something that even already practicing technicians can pick a few lessons from. And probably you can go and rectify if you think that whatever I mention here is worth listening to. So my name is David Omach. I'm an instructor of electrical and solar installation at Butere Technical Training Institute, and this is our private academy. Now, there is a question of whether to. Okay, there are several questions. I don't want to ask. I don't want to repeat the question, so I just want to explain. And if you have a question that is related to whatever I'm going to explain, I hope it will have answered it. Although I'll still review this same issue over and over. Again, whatever I said, the YouTube channel, you can go over to our YouTube channel, Safa Electrical, or you can type the TVET EDGE by Safa. We are building a bank of knowledge, and if you think there's something there that is worth watching or listening to, please go ahead and interact. And the reason why we are building is so that in the future, whenever there's a question, we can just go back and review some of the footage that we've created. And so it will be easier to answer new technicians who are interacting with our work as we grow. So, and by the way, for you, we would like you to support us as much as you can. Please like, share, and subscribe. Ask as many questions as you can. Comment on our work, share it with your fellow students, fellow technicians, share it with clients, because I'm also a proper or a certified technician. I also do domestic electrical and solar installation. For us to keep doing this, we need also to raise funds to keep supporting this. And if you would like to support us also directly, you can send it to our contact. This is our contact. Yes, you can send it to this contact. Support us. You can send either funds directly or whatever accessories that you think we might utilize for training. Reflective vests, these softboard markers. We need also things like ink, whatever is necessary or useful in the classroom for both the theory part and the technical part. Behind me, there's our practice board, which is just exactly opposite this board. So I'll share once I'm done preparing it. So let's get back to it now. Hopefully, as I've said, if it will answer your question, fine. If it won't answer, you can ask that question. I compile at least 3 or 4 of them and then create another video for that. Now, in a domestic electrical installation, and I'm talking to students who are probably doing level 6 of the KNQF CDAC system or the diploma, the NEC diploma. So most of you are technicians who will be doing this kind of work. You receive a request from a client and he wants you to install a solar panel on the roof, an inverter probably between 300 watts, normally the smallest ones in the market currently 300 watts all the way to 10 kilowatts, a battery bank as small as 100 H all the way to, it could be all the way to 1000 H depending on the client himself. But that aside, so you have done, you have finished your installation, and some of the things that you need to do is protect your system. You are supposed to design a protective protection devices to be in line with the system that you've installed. Now, the first thing we had mentioned about the mains earth pit. So this is essential, or this is important even for mains electricity, that is KPLC electricity. So we said that our mains earth pit shall be located at least 1.5 meters away from the edge of the wall. 1.5 meters from the edge of the wall. And I have covered this in a a different video. You can go over it, you can listen. I have explained why we need 1.5 meters away from the edge of our wall. So our main earth pit is going to take care of the mains system earthing, that is mains from KPLC, and you will have to bond the solar panel mounting structure, or apart from the solar panel mounting structure, you can even bond the panels themselves. So essentially, if you bond the mounting structure, it's conductive. So the frames of the panels, give or take, let's assume they'll also be bonded, but you can just go ahead and bond them. Each and every panel, you bond them to the mounting structure, and you bond everything to the same mains earth pit. So essentially what this prevents the solar system and the mains electricity from having two different potentials. When you bond them together, whatever potential rise happens on the CPC or the grounding or the earthing system will rise and fall equivalently. So the frame of the inverter and the frames of the panels will not have a different earthing potential to the rest of the components in the house or the accessories. So it's essential that you bond the inverter, the panels to the mains earthing system, and you use this the main earth pit. Different configurations will require you to have more than one earth pit. I have mentioned and said, analyze the structure first, analyze the installation. Those decisions, we'll talk about them in full, so that once all these videos are up, it's easier now for a student to know what they're looking at. So let's not talk about that for now. Now, you have your lightning arrestor on top of your roof. In Kenya, in most cases, in Kenya, in Africa, we are using aluminium. It's the most common material. Like on average, out of every, let's say 10 homes in Kenya, 7 homes have got aluminium iron sheets on average. So aluminium as a material, as an element, aluminium conducts electricity. It might not be as good as copper, but to some extent, aluminium will allow a certain amount of electricity to flow from point A to point B. Having that in mind, the IEC regulations, I'm not going to quote the numbers as of now. We shall be looking at those because I'm supposed to teach IEC regulations in module 3. I'm teaching them as from January. So I don't want to quote them now. They're when you are reading regulations, they are normally a bit confusing if you just go into one regulation straight. You're supposed to build from the base regulation, go to its alternatives, what we call recommended deviations if you have to deviate. So I don't want to send you to an exact regulation, but the IEC regulations demand that the lightning arrestor, this component here on top of the roof, should be at a distance of S from any electrical or metallic structures. There is supposed to be a distance S, and for domestic systems, that distance has been recommended. So most of the now the guides are recommending 1 meter. At least a distance of 1 meter between the lightning, the antenna, and the solar panel mounting structure, or any other metallic structures. You can have on this same roof solar water heater, or probably a water tank, or any other thing. So the distance between this arrestor and all other components that are electrical conductors is supposed to be 1 meter or even more. That's the first regulation. It's so that whenever there's a lightning strike and this arrestor picks the current or the charges from the air, it sends all that charge or current deep into the ground. If you have metallic components, let's say this is your arrestor, and you have components that can conduct near it, we can have something called an arc flash. An arc flash might occur between the arrestor and the metallic component. So an arc flash basically occurs when two conductors are near each other but not close enough to have a continuous path for electricity to flow. So an arc flash will occur. You will see something like fire. That's the basic term I can use. You can see a small blue fire in KPLC. Most KPLC technicians will have witnessed this when they are either restoring power to a high voltage transmission line, when they are using the link stick to refuse those junctions. Just before you connect the fuse, there's normally a blue or yellow flame appearing. So that's an example of an arc flash. It's current moving from one region to the other, but not following the path, an actual conductive path. So when we have two metals close to each other, the lighting arrestor and another metal, if it's less than 1 meter and there is enough charge, it was a proper lightning strike, it will flash and hit either your panels or any other electrical component. So that is number one. There has to be a proper distance between the lightning arrestor antenna, or we can call it an antenna or a rod, depending. Now the different regulations call it differently. Some regulations call it an antenna, others call it a rod, but you get the point. The distance between it and any metallic part should be 1 meter or even more. So I have mentioned, because most Kenyan homes are using aluminium as the roofing material, it's normally aluminium or an alloy of aluminium and zinc, but in most cases this material will conduct. The lightning arrestor has got components. In full, it's called a lightning arrestor, but it's a system. So it has got the rod, the down conductor, and the earth rod. Now, according to regulations, this lightning arrestor should not sit on the roof directly. This lightning arrestor should not be mounted on the roof directly. And by directly, I mean, if this is the surface of the roof, assuming this is your roof, up here you have your roof. So let's just use the flat surface, and you come with your arrestor. The arrestor has a base. There's normally a base platform where you screw in this rod. That base should not sit directly on top of the aluminium of your roof. That's another regulation that I realize that most people normally overlook. It is according to regulations, you're supposed to have insulation, a material that is a non-conductor for the very basic systems between the base of the lightning arrestor and the aluminium surface of your roof. That is one regulation that most people overlook. So if this is your arrestor and assuming this is your base, you screw it, this base here should not settle directly on top of your roof. It should be raised, and in between the base and your roof there should be a non-conductor. What does that prevent? This is the explanation. In case of a lightning strike up here, and lightning normally comes with very high currents or charges, these charges will look for the shortest route into the ground. That's the most basic explanation. But in the event, during that event, they will always find the easiest paths, or the least resistive paths for them to flow before they get to the earth rod. Now, when that happens, when the lightning arrestor receives these charges, those charges will come to the base here, and they will want to dissipate into the entire section of the roof before they come back and realize, no, the roof has got no exit point, so let's just go back, find another route all the way to the ground. It will happen so fast. Technically, this is just an explanation, but it normally happens so fast, within the splash of a second. But on top of the roof, they might get into the metallic structures. That is one thing you have to remember. That is if this arrestor is sitting directly above the roof surface. These charges might get into the base here, and that base dissipates some of it into the metallic structures that have been mounted on the roof, directly on the roof. And these metallic structures include the aluminium or steel or the aluminium or steel structures that are supporting your solar panels, or even the aluminium frames that are supporting your solar panels for those who mount panels directly on the roof. So to prevent that, number one, you should get insulating material between the base and the roof structure. The down conductor now connects the rod, the not the rod, it could be the antenna or the rod to the earth rod. In domestic electrical systems, it is essential that because these are small houses and the roof structure is normally compact, so we have got a lot of activity going on the roof for small houses, it's essential that you get a cable that has been heavily insulated, high voltage, or a cable that has got high voltage insulation. That is one thing you have to keep in mind. For small roof structures, you need a cable that has got high voltage insulation to ensure that in case a strike happens, that cable, because a section of this cable will be lying over the roof, because this arrestor is not, in most cases, the arrestor might not be at the edge of the roof. It could be at the center. When you look at it from above, this arrestor could be at the center of the roof. So the distance between the arrestor to now the edge of the roof and then down, that cable is supposed to be uh, insulated for high voltage. Now, high voltage means the basic low voltage normally range between 0 to 1000 volts. Some books say between 0 to 1500 volts. So high voltage insulation means voltages above 1500 volts, depending on now the regulations that you read. Some regulations say any voltage above 1000 volts have already crossed over. To be safe, you need to get a cable that has insulation of above 1000 volts, DC or AC. It has to be 1000 volts. It has to be insulated for above 1000 volts for either AC or DC, from your roof to your earth rod. The question of why a lightning strip is laid naked, I've looked at that. It's a different regulation, and we shall look at it also in a different learning session. A lightning strip is normally naked, I agree, but the regulations that govern it are different from the regulations that govern this. So when you are laying this down conductor, try and avoid using a path that has got other electrical cables in it. By that, this is what I mean. The path that you use from the rod to the ground should be free of any other electrical installation, work, or cables. So you use a path where this cable just go from the antenna all the way to the ground without having to cross either probably on the wall section outside here or on top of the roof, without having to cross other electrical cables, either to cross or to lay alongside other electrical cables very close to each other. So you pick a path that you know no more electrical installation work is going to happen, to avoid laying it either close to other electrical cables or across electrical cables. So that is to prevent things like induction, electromagnetic interference, or even the arc flash, and very many other issues. Now, another thing you have to remember, this earth pit is supposed to be different from the main earth pit. The earth pit of the lightning protection system is supposed to be different from the main earth pit. And some regulations say that this earth pit should be at least, you see the zones, we have got zones. If you look closely, this one for the main earth pit, I said at least 1.5 meters away from the building. This one should be more than. So if this one is at 1.5, you can go another 1 meter. That could be zone 1, and then on zone 2 now, probably at the second meter is where you now locate your earth pit from the lightning arrestor. So you also have to ensure that the distance is maintained. The distance between this earth pit and this one, and number 2, the zone. If this one is 1.5 meters away from the wall, this one can go a bit further, probably 2 or 3 meters away from the wall. Another thing, you are advised that the solar panel mounting structure should also, something to keep in mind. For example, this is your roof structure, and you have got a lightning arrestor up there. So when this happens, the solar panel mounting structure should not go directly on top of your iron sheets. That is one thing also you have to keep in mind. When you mount the solar panels directly over the iron sheets, irrespective of all the other protective parameters that you have put in place, you are we normally say in protection, you start with first by eliminating. There's a hierarchy. I'll list it somewhere. Sorry, we'll look at hierarchy. I'm about to upload the video on site survey, or yes, site survey for module 3 students. So there's a hierarchy of protection. Number first, if you can eliminate the issue, eliminate it all at once. So when you mount your panels over the iron sheets, what happens is that in case of a fault, such a fault, the iron sheets might conduct through the metallic structure of the solar panels frames and damage your solar panels. So what happens is that you are encouraged to use again another insulative or an insulated barrier between the metallic frame of your solar panels and the roof structure. So what essentially that means that you should also have at least 2 layers. By 2 layers, I mean, if this is your roof, if this is the surface of the roof, you first come with an insulated material, you mount it here. This is a material that does not conduct electricity, and then you screw it to probably the timber of the building. And then you come now with your metallic structure that is hosting now the panels or the aluminum frames, and then you screw them separately. Not, remember, the screws from these the screws on the upper side, or the screws from the metallic structure that is supporting the panels, should not meet the aluminum frame of the not the aluminum frame, the aluminum or the iron sheets. So let me just say that again. For example, this is your roof, aluminum. You come with an accessory that is an insulator. That is what goes on the surface of the roof here. And then you screw it to, it could be the wooden structure of the roof. So you screw this one into the wooden structure. So this is the insulating material, this is the wooden structure, this is the aluminum roof. And then now the aluminum frames or the metallic frames that are supposed to support your solar panels now, or the solar panels themselves, you come with them on top here. And mount them now on top of the insulating material here. And then you screw these ones in. So what that means is that you ensure that the screws from these aluminum frames or metallic frames of the panels do not meet the aluminum iron sheets. So we'll have like it's like a floating system whereby these aluminum frames have been screwed to the insulating material, and then this insulating material has been screwed into the wooden structure of the roof. So essentially, I don't know if I'm selling that picture visually well, but what I mean is that the screws from the aluminum frame should never meet the iron sheets of the house. So you have two sets of screws. You have the first set of screws that will screw the insulating material to the iron sheets, and then when you come now with the aluminum frames, when they settle on top of this insulating structure, you screw them in. So essentially, you need to have something a bit thicker to allow this to happen. So what that does is that it allows you have a proper insulation between the roof and the metallic structure or the aluminum structure of the solar panels. That is one thing you have to remember. So at the end of this short learning session, I don't know if I've answered any question. What you should keep in mind is that, number one, whenever you're introducing a lightning arrestor, it has to be far from the structure that you are trying to protect. That is one. If it has to be on the roof, there should be a very safe distance of 1 meter plus between the lightning arrestor and any other metallic components or conducting components on top of that roof to avoid arc flash and other potential faults. That way you'll have at least protected your system in the recommended ways as per regulations. So we shall look at those regulations. We have got IEC regulations, we have got IE regulations, and I'll start introducing them slowly by slowly. There are a bit many. IET is around 500 pages long. We cannot go all over them at once, but whenever we have to mention something, I'll now be quoting the base regulation, and then we can go around it, because with regulations you normally read the first regulation, you look at the recommendation, the allowed deviation and such. So having said that, I know there are technicians who've mounted their lightning arrestors directly on top of roofs. Do your research. If you think these will help you in one way or the other, go do some extra research on whatever I've just mentioned. Go and rectify that system. If we have technicians who've installed a separate earthing system for the inverter and the solar panels away from the main earth pit, go and bond them together. Any other thing that will pop up along this same learning session on YouTube, when I start arranging those videos, depending on, I'll create now playlists for these videos so that when you start looking at one, you can build on it slowly by slowly. We shall cover it. Thank you for listening. If there's something that I've not explained well, kindly comment, let me redo, and let's meet each other in the next one.